So you look at the two formulas. I'm having R series, R1 plus R2. So that will be the series connection. So this one, it will be my parallel connection. So I'm happy I can choose this formula. So that formula, it will be, this is 6.1, I mean 6.1.2. My 1 over Rp, which is R parallel, is equals to 1 over R1 plus 1 over R2. So it's 1 over R1 and also 1 over R2. So 1 over R1, I'm having two resistors. This one is 1 over 6 plus the other one, it will be 1 over 4. So I'm having 1 over 4. So now I'm going to look at the lowest common multiple. I can say it will be 12. So 6 goes how many times there? It will be 2. Then 2 multiplied by 1, that will be 2. Then I'm having plus. The 4 goes how many times into 12? So it will be 3 times. 3 multiplied by 1, I'm having 3 there. So I'm having the 5 over 12. So I'm still having 1 over Rp. So what I want to calculate, actually I want to calculate Rp. I'm looking for that one. So I can do cross multiple. So it will be 5 Rp is equal to 12. Then I divide by 5. So therefore, my R parallel is equal to, then I take out my calculator. If you take the calculator, so it will be 12 divided by 5. So I'm getting 2,4. So I'm getting 2,4. It will be an ohm. This is one of the options that I can use to calculate the effective resistance of combination of the two resistors. So now copying the original formula there. So it will be the 1 mark for the formula, then you substitute. Then now because this is 3 marks, the final answer, it will be that one. Or we can use that method, but this method can only be used if I'm having 2 resistors, which is R parallel. It will be the product. It will be the product over sum. So product, it will be multiplication of the 2 resistors, which is going to be 6 multiplied by 4. Then I'm having the sum is the addition. It will be 6 plus 4. Then you take out the calculator. Ultimately, you're going to get the same answer, which is 2,4 ohm. It will be the mark for that one, the final answer, and mark for the substitution, and also awarded the mark for the formula for that case. That is why I'm having 3 marks for this question. Okay. Then the question continues to say, now, what will be the reading on A3 when the switch is closed? So now you can see we have already answered that question. So the answer is 2 ampere, but now let me write it down. How do you write that 2 ampere? How did you get it? 6.1.3, 6.1.3. You say I'm having I total. So I total is equal to I, the current going to pass to the 6 ohm resistor, plus the current that is going to pass the 4 ohm resistor. So now the total, I total, then we know it will be 5 ampere. So the total current, that will be 5, but the total passing through 4 ohm resistor is given as 3. So you want to calculate the total current passing there. This one is going to be 3. Then ultimately you're going to say the total, the current passing through 6 ohm resistor, it will be 5. Then you transpose this one to be that side because it's positive. Then it's going to change the sign. It will be 5 minus 3. We get 2 amperes. So that will be the easy way of calculating it. That will be 2 marks for that one. So for 6.1.2, we are done with that question. Then let me go to 6.2, but I need to read the statement. Consider the circuit below. When the switch is closed, the V1 read 4 volts. Now R2 read 1,6 volts, and the voltmeter V4 read 1 volt. All right, so meaning they're talking about this circuit below there. It will be this circuit below there, not the one at the top. So the circuit below, when the switch is closed, the switch is open. So I'm having V1 there. The V1 is 4 volts. So V2, now V2 is 1,6. So this is amount that of energy which is going to transfer to that resistor, which is 8 ohm resistor. Then the last one, the 1 volt, it will be for that one of 5 ampere. All right, let me check the questions, but immediately. Okay, thank you, Mr. Nambani. Okay. 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 Okay, thank you, sir. I'm sorry about that one, Mr. Naman. Okay. All right. The 6.2, the 6.2 is a series combination. So in a series combination, what I know that current, which is the total current, will be the same, meaning the current passing through V2, which is I2, will be the same as the current passing through V3, will be also the same as the current passing to V4. So current will be the same for that manner. Now, what is not the same? So this one is the same throughout. So in a series, the current will be the same. If an example, the current passing there is 2 amps, the current that is going to pass there, it will be 2 ampere, as well as the current that passing there, it will be 2 ampere. It will be different to the combination of resistors in parallel. So let me go back to slow down. Thank you, Mr. Nambani. In a parallel combination, the basic that you know, so the current here, not the same. The current, not the same. The current is not the same. But what is the same in a parallel combination? If you look at this formula, Rp, R1, and R2. What does that indicate, that one at the top there? For you to remember that in a combination, meaning I can connect the voltmeter here, I can connect the voltmeter at the top. So this voltmeter, if I'm having 2 volts, so that voltmeter for connected to 6 ohm resistor will be the same as 2 volts. So meaning in a parallel, that one at the top simply means it stands for the V. V is the same. V will be the same. So the V will be the same in a parallel combination. So potential difference is the same in a parallel combination. So to remember this, if this formula I'm having it, what does that indicate? The one at the top, it simply means the potential difference is the same. If it's the same, we are going to say the V total will be the same as V connected. I can have V1 and V2 will be V1 and also the V2. But to calculate the current is not the same. So current I total is equals to I1 plus I2 plus we can have so many branches. So once you see plus, it's not the same. But once you see the equal and equal, potential difference will be the same in parallel combination. Now, this one in a parallel, that will be a current divider. So parallel combination is a current divider. Current, it will be split. Remember, the current, conventional current from positive terminal to the negative terminal. The current is going to be divided here, so it will be current divider. Thank you very much. Then, but if you go to the series combination, what is the same there? It will be the current. But what is not the same, it will be the potential difference. V total will be equals to V1 plus V2 plus V3. So meaning, if you talk about the potential difference, I'm referring to that energy. The energy that is going to transfer to 5 ohm resistor is not going to be the same as the energy which is going to transfer to 7 ohm resistor as well as 8 ohm resistor, because these resistors are not identical. If they were identical, they're going to share the same energy, but this one are not identical. We look at this 5 ohm resistor. 5 ohm resistor, I'm having the potential difference of 1 volt. 8 ohm resistor, I'm having 1,6 volt, meaning the higher resistance, that will be more energy needed to dissipate per coulomb of charge. So meaning if I'm having higher resistor, I'm expecting to get the high energy for that metal. This one of 7 volt, this one is 8, this one is 7. Meaning for V3, the answer that I'm going to get, it must be less than 8 ohm resistor, if you look at that one. So the total energy, which is 4 volts, this energy, I'm going to divide amongst the resistors which are connected in series. So this amount of energy will start from that side. I'm having 4 joule of energy. So coming to this side, this is the packet that I'm having. I'm having that energy. So for this 5 ohm resistor, how much energy I need to give this 5 ohm resistor? I'm giving it 1. So what will be left? I'm going to be left with 3 joule of energy. So once you'll be left with 3 joule of energy, how much I'm going to give this 7? So this one, it will be question mark. But what I know, this side is given for V2, how much is going to be transferred is 1,6 joule of energy. Then now I need to calculate for V3.
Thank you.
I can see the hand.
Morning, sir. Morning, sir. I just want finding you, sir. So I was just asking for them to move the paper a bit upwards so I can see the second circuit. Yes, sir, it was the only one. Thank you very much.
I was going to ask the same thing.
Okay. Oh, thank you, sir. Okay, thank you very much, Ntate Nambani. Let me go back again. I'm sorry about that one. My good dear learners, the circuit is a series circuit. So in a series, the current will be the same, but now what is different, it will be the amount of energy that has to be transferred to resistors connected in a series. So now the series connection, that we call it what? The potential divider. So meaning, so that is not the same, not the same. What is not the same? It will be our potential difference is not the same. So it will be potential divider. So potential divider, it simply means if I'm having this 4 volt, this 4 volt, I'm going to divide it among the resistors. It simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it among the resistors. Simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it among the resistors. Simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it among the resistors. Simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, 4 volt, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having, for example, that's 4 volt, this 4 volt, the amount to divide it simply means if I'm having. I can hear you this side.
We can also hear you, sir.
Do you hear any echo, Tsepang?
No.
Okay. So I'm audible now. Okay, thank you very much, Mr. Nambani. So as indicated, that amount of 4 joule, so it will be the same as 4J, 1 coulomb of charge. So I need to transfer that amount of joule, J per coulomb. So it will be that unit of volt. So it will be that unit of volt. Okay. Now I need to calculate how much energy that has to be transferred to V3. So it will be V total. So V total is equals to V1 plus V2 plus V3. This is 4. V1 is given there is 1 volt plus V2 1,6 plus V3, that will be unknown. So it will be unknown. So to get V3, it must be 4 minus 1 minus 1,6. That will be my V3. So it will be V3. So I'm having 4 minus 1 minus 1,6. So I'll be having 1,4. So definitely this is 1,4. volt. And I'm happy to get 1,4. Why? Because remember, this resistor, 8 ohm resistor, the amount of energy will be 1,6. This one is smaller than, the 7 is smaller than 8 ohm resistor. So the energy also, it has to be less than 1,6. Now the energy I'm getting there is 1,4. So I'm happy about V3. I know my V3 there, my V3 will be 1,4 volt. My V3 will be 1,4 volt. So let me go to the questions. The first question, calculate the effective resistance of combination of the 3 resistors. So the 3 resistors, they are connected in series, meaning it will be R series, R1 plus R2 plus R3 plus R4, whatever the numbers of the resistors been given. So 6.2.1, so 6.2.1 R in a series. I think they can also follow that one. It will be R1 plus R2 plus R3 because there are only 3 resistors. R1, I'm having 5, 7, 8. So I'm having 5 plus 7 plus 8. This one, you don't have to use the calculator. This is the simple addition arithmetic. So I'm having, it will be 12 plus 8. So that will be 20 ohm. So the formula, everything is correct. And also the final answer. So I'm having 3 marks for that one. Then determine the reading on V3 when the switch is closed. So they want the V3. So now V total, this one is not in the formula sheet. This one is not in the formula sheet. So I need to have my tools. So this one is not in the formula sheet. The V total is equals to V1 plus V2 plus V3. So now 6.2.2, 6.2.2. I think it's already been calculated. Let me not repeat what I've already done there. So this is 6.2.2. Actually, it was already been calculated above there. So this is 6.2.2. So it will be the formula V total. I'm sorry. The formula V total is equals to V1 plus V2 plus V3. So now, just to have this combination and also the final one, which is 1.4 volt, that will be 2 marks for that one. So that one was already been calculated. Then the 6.2.3, 6.2.3, if the current passing through 8 ohm resistor is 0.2 ampere. So the current passing, now if the current passing through 8 ohm resistor is 0.2 ampere, what will the current through 5 ohm resistor be? And explain that one. So they want the current passing there. All right, now let me go back to my tools because these are not the formulas being given. So myself, the tools, you must know your tools. If you go to electricity, which tools I'm going to have. So this tool, you need them. Now, what is the same there? That will be the current. It simply means if the current passing 8 ohm resistor is 0.2, it will mean that the current passing through 5 ohm resistor will be 0.2 amperes. So now, the reason you need to explain why are you saying that. So you'll say, now what is the same? What is the same? Meaning it will be the current. The current will be the same throughout. So you'll say the current will be 6.2 6.2.3. So it's 6.2.3. The current passing through 5 ohm resistor. So it will be the same as the current passing through 8 ohm resistor, 0.2 ampere. Why? Because the current is the same. Current is the same in a series connection. So meaning my current is the same. Current is the same in a series connection. If we need to extend this question furthermore, so what will be the current passing through 7 ohm resistor? So it will be the same as that one because the current will be the same throughout. The current will be the same throughout. 6.3, a charge of 48 coulomb. So I'm having 6.3. The charge of 48 coulomb flows through a circuit in 2 minutes. So now calculate the current flowing through the circuit. So the data, what is given there? I'm having the charge. I want to calculate 6.3. So the charge, I'm having 48 coulomb of charge. Then I'm having the time 2 minutes. Then now it simply means I need to calculate that current. So my challenge is I can go to my formulas. I can go to my electric circuit formulas. What I'm having here, I'm having that formula of I is equals to the Q over change in time. So I can immediately going to pick up that formula, change in time. Then now, the time now is in minutes. Always I need to change it to be in seconds. So now I need to change time in seconds. So I can say 1 minute is equals to 60 seconds. So how many minutes? I'm having 2 minutes. That will be how many seconds? So now to get this 2, which factor I can multiply to get 2? If you say 1 multiplied by 2, you get 2. That side, if you multiply by 2 this side, that side I'm also going to multiply by 2. So this unknown part is going to be 120 seconds. Or if you don't want to use this method, 1 minute is equal to 60 seconds. So this is the 2 minutes. This one will be X. This one cancel out. You can do cross multiple. You can do cross multiple. So X multiplied by 1 is X. That will be 2 multiplied by 60. So I'm getting 120 seconds. So now there are various ways of doing it, but I prefer if you're using this one, it's more convenient to everyone, that one. It might be complex if you're having the decimals on that side. All right, so this is the formula. Then you substitute the charge is 48. Then the time is 120. Then now you just take out the calculator. So it will be 48 divided by 120. So now I'm getting 0.4 on this side. That's 0.4 ampere. So I'll be having a mark. How many marks for that one? I'm sure this one is 3 marks. Yes, it is 3 marks. So it's a mark for this one, it's a mark for that one, it's a mark for that one. So I'm having the full 3 marks for this question. So then if you look at the paper, or that's one of the past question papers, the question for for this electric circuit was 18 marks. So you can just look at one or two, even one question for multiple choice questions, because you need also to have the skill how to answer the multiple choice questions then. So I'll check if multiple choice questions. I'm not sure, Mr. Nambani, do you have any questions from that side before I'm going to move to another topic? So thank you, Mr. Nambani. Because this is electricity and magnetism, let me do this electric circuit together with electrostatics so that I know I'm done with the part of electricity and magnetism. So I don't want to touch and mix my things this side. So if you are doing electricity and magnetism, I need to stick there. If I go to another topic, it will be the topic that stands alone itself. So this one, don't think I'm going to take more time on it, because it's only 14 marks. It's only 14 marks. I still quite remember that this is one of the easy marks that learners they can grab for this June examination. That will be administered tomorrow. Remember, tomorrow you are writing a full paper, which is out of 150. I'm checking my thing this side. I'll go back to the multiple choice questions. I don't see where did I put my multiple choice questions. But now let me carry on. Let me carry on the electrostatics. The electrostatics, the formulas for electrostatics. We have the one that is most probably everyone know in electrostatics is when you calculate the new charge. I'll explain what's happening here. It's one of the tools, because if you look at my question paper here, maybe it's another page. I don't see everything. Okay, I'll check the formulas for electrostatics, but this one definitely new charge, you need to know it. Once we have the two charges, they make a contact and separate. This one, you use it once the charges make contact and separate. Definitely I'm going to use this formula. The second one, to calculate the number of electrons, so it will be the charge over elementary charge. So definitely I'm going to use that formula there. So it's very important to know the two formulas. Okay, now without waste of time, let me strictly go to question 5. So question five. All right, question 5. two insulated, we start with this one. The electrostatics, normally we study the charges at rest position. So meaning the electrostatics, so is a study of charges at rest. So meaning the electrostatics is the study of charges at rest. So now there is a reason why we use what we call is two insulated. So if I'm using insulator, so the insulated is the same as I'm using what we call insulator. So the insulator is the material that or material that do not allow electricity to pass through. So meaning if you are referring to insulator, is that material the material that does not allow the electricity to pass through. But if you talk about a conductor, so obviously this conductor will be the material, it will allow electricity to pass through. So as an example, if it's raining outside there and it's a thunderstorm, so it will be wiser if you need to be in a safe place, you can be inside the car. There's a reason why you must be inside the car, because the car, it has the tires. So those tires, they are going to prevent the charges to pass through. So what is important about the tire is insulator. So those tires are the insulators. They are going to prevent the charges to pass through. That is why they are saying if you need to be in a safe place, you must be inside the car. So it's one of the example of insulated. Or you say, now if I'm using insulator sometimes you can say is to prevent the weight. They can ask you why I'm using insulator. Now to prevent the charges not leak to the ground. So meaning now I'm having the two charges as is indicated in the diagram here. I'm having -8 coulomb, I'm having +20 coulomb. So now because of this insulated, I need to know insulator. So I'm using that one so that to prevent the charges not leak to the ground. That is very important for electrostatics. This is important for electrostatics. All right, then let me read the statement. Let me read the statement, then we can answer the question thereafter. Two insulated graphite-coated polystyrene spheres, which is A and B, are suspended from the threads. The sphere held apart a small distance. Okay, that's a small distance which is separating the two spheres. The charges on the sphere A and sphere B is -8 coulomb and also +20 coulomb. So now what we need to remember if they talk about this coulomb, so they can give you several coulombs of charges. We have the millicoulomb, we have the microcoulomb, we have nanocoulomb. So, but now what I like about this question, they didn't give you micro and also nano and milli. That is a straightforward question. But if suppose that this was -8 microcoulomb, the other one is +20 microcoulomb. So we need to change the micro. So how do you change this one? The milli is 10 to the power -3 coulomb. The micro, 10 to the power -6 coulomb. The nano is 10 to the power -9 coulomb. So if I need to change this one, I will say -8 multiply by 10 to the power -6, that will be coulomb. This is how you change that U there. You say -8 multiply by 10 exponent -6. Obviously, that one, how do you change that one? 20. That will, I'm sorry. 20. Then you multiply. It's 20 multiply 10 to the power -6. That will be Coulomb. I'm happy about that one. All right. So -8 Coulomb and +20 Coulomb. Please indicate that positive. Just indicate it. I know even if you don't write it there, you must indicate that's a charge. So it's positively charged. This one is negatively charged. So the respectively, when the spheres are released, they move towards each other. So now they move towards each other once you release them. So, okay, 5.1.1. So now I need to answer my questions. 5.1.1. Explain why the spheres move towards each other when they are released. Okay, before I can answer this one, I think it's also important to indicate if I'm having negative and also positive. Let me also have some notes to give you some of the information that I think you can need. If I'm having a ruler, positive, negative, positive, negative, positive, negative. So I'm having electrons and also what we call the protons, if we talk about it in an atom. So this ruler is neutral because I'm having positively charged and negatively charged. You can talk about protons and electrons, okay? So if you are referring to the structure of an atom in a nucleus, we know it's surrounded by the number of protons and also the number of neutrons. So I'm having an electron there. So this ruler is neutral. Then if you take a ruler and you take a cloth, so you wrap a ruler with the cloth, what actually you are doing there, either you are adding the electrons or you are removing the electrons. The protons, they don't move. You don't move the protons, they're always there. So even here, if this ruler is neutral, to be negatively charged and to be positively charged. So you say, oh, all right, now I'm having negative, positive, negative, positive, negative, and negative. So the negative, they are more than positive. So it will be negatively charged. So if this is negatively charged, so meaning the electrons, they were added. The electrons, they were added. I can have, or maybe it was taken from neutral, you can have 3 positive, 1, 2, 3, or maybe you want it to be like this, and I'm having negative. But because negative charges are more than the positive charges, what you know, electrons were added. But if this ruler comes to be positive, negative, positive, negative, positive, and positive. The positive are more than the negative. So this ruler, it will be positively charged. So if it's positively charged, what happens to the electrons? The electrons were removed. So that this question, you need to be careful of it. If this ruler is negatively charged, electrons were added, meaning we talk about electrons, we talk about electrons. So we are not talking about the protons, we only refer to electrons, okay? All right. Now, explain why the spheres move towards each other when they are released. So meaning, now if you talk about electrostatics, it will be 2 types of charges. It will be positive and positive, negative and negative. That is grade 9 work, negative and negative. We know unlike charges and the like charges. We talk about the force of attraction and also the force of the repulsion. So this one is negative, this one is positive. Obviously, they are going to attract each other. So explain why the sphere move towards each other. So 5.1.1 will say, so 5.1.1, now the spheres are carrying, we can say the spheres are carrying carrying opposite charges, or it can be unlike charges, opposite, or you can say this will be the unlike charges. And therefore, if these unlike charges and will attract each other. So meaning, now what is important about the first part, because this is opposite or unlike charges, and if this is unlike charges, what actually they are going to do, they will attract each other. So meaning I'll have 2 full marks. So don't just say attract each other. Why they attracting each other? Just to indicate to your teacher or someone who's going to mark a script that you know the physics. You say the spheres, because they are unlike charges or the opposite charges, then they will attract each other. So that is a scientific way of answering this question. All right. So then the next question, which one of the 2 spheres has excess electrons? So what does that indicate? Has an excess of electrons. So it simply means I'm having more of electrons. Which one is having more electrons? We look at this. If this is negatively charged, so I'm having more of electrons. I'm having more of this. So if this is positively charged, I'm having less electrons because electrons were removed. But if this is negative, they are about more because electrons were added. More added. Less, it will be removed. So we look at the sphere, which one of the 2 spheres we have an excess of electrons. So we can just write down sphere A or sphere B. So this sphere B, sorry, not sphere B, but the sphere A will be the one that is going to have more, even if you count. So we want to balance. I'm having how many positive? 1, 2, 3. I'm having how many negative? 1, 2, 3. So these 2 electrons, they're having what we call an excess of electrons. I'm having 2 left because we want to make it neutral, but I'm having a problem. I'm having still more of electrons. So you are saying these electrons are in excess. So it will be my sphere A for that matter. All right. 5.2, the 2 spheres are allowed to touch each other and then separate. They touch and then they separate. If they touch and separate, then you have the tools. Remember, if they're going to touch and separate, I can expect this question. They made the contact and separate, I can calculate what to call the new charge. All right, let me just quickly check the question there. So 5.2.1, calculate the charge on each sphere after they made a contact. So simply means I'm going to say, all right, 5.2.1, I'm going to use that 5.2.1, I'm going to use that formula to say the new charge. It can be Q new is equals to Q for A plus Q for B divided by 2. But if there were about 3 there, if suppose that I was saving A, B, C, you are going to divide by 3 because they're about 3. Now 1, 2, they made the contact and separate. That is why we divide by 2. We need to be careful with that one. Q4A, the charge, okay, for now, we haven't done the scalar and the vector quantity. I want to explain why we need to indicate the negative and charge. But never mind about that one. So it will be -8 plus the other one, which is 20 divided by 2. So now it simply means If I'm having 20 and 2, it will be positive, then divide, which is 12 divided by 2, I'm getting positive 6 coulomb of charge. So now I'm going to get 6 coulomb of charge. That will be my answer for 5.2.3. It will be the mark for knowing that formula, the tool. It will be the mark to substitute. It will be the mark for the final answer for that case. But if maybe this charge is -8 microcoulomb plus 20 microcoulomb, you can do this to say, all right, so this is an extra information. I'm having -8 microcoulomb. Don't change it here to say plus 20 microcoulomb, then divided by 2. So you're going to get positive 6 microcoulomb. Therefore, you can say that is 6 multiplied by 10 to the power -6. That will be microcoulomb. Or you can just strictly change it there. I'm sorry about that one. You change it to say -8 by 10 to the power -6 plus 20 by 10 to the power -6, you divide it by 2. But most probably I prefer, even if you write it like this way, you can change the last part if you want it there. All right. So that was question. Calculate the charge on each sphere after a contact. Meaning after a contact, each charge is going to carry positive 6 microcoulomb. After they made the contact, each charge is going to carry positive 6 microcoulomb. Then now 5.2.2, I was getting a clean page. Will the force now be on attraction or repulsion? Give a reason for your answer. What will be the force now? So A, that sphere for A, this is sphere for A, is positive 6 coulomb of charge. So that sphere of B is positive 6 coulomb of charge. After they made the contact and separate, now you need to consider, you're not going to take -8 coulomb and positive 20 coulomb. Why? Because now this statement is 5.2.2 now is part of 5.2.1. You can't go back to 5.1, but they made the charge and separate, you are using the new charges. So what do you think? If I'm having positive and positive, what will be the force there? So the force, it will be the repulsion. It will be the force of repulsion. Why you say the force of repulsion? Because of what? Because now they're both being positive, we can say the like charges and the like charges and the repel each other. So because of it will be 5.2.2, then you write it down, it will be the repulsion. So because why the repulsion? It will be it will be like charges. Like charges, not unlike charges. It will be like charges because they're the same. Now repel, like charges, now repel each other. So meaning they repel each other. Thank you very much. So 5.2.3, the principle of quantization of charge, 5.2.3. So it will be advisable, more or less, you need to check your examinable content. You need to check examination guideline. The charge cannot be created nor destroyed, but mainly transferred from one form of energy to another. So this principle, check exam guideline. because I'm checking my time now, it's almost 10 past 10. I'm still need to go to chemistry part, and after chemistry part will be done, we'll check if you can go to term 1, calculate that we go to electromagnetism and sound waves, sound and light, if I still have time. So 5.2.3, just quickly go and check example content. Determine the number of electrons transferred. I'm interested to the content. You must calculate the number of electrons transferred between the two spheres during the contact. So this one is 4 marks. So now if I need to transfer this charge, so you transfer from where? So I'm going to say, okay, I'm going to choose either this one or that one. Let me say for A, let me check sphere A. This side I'll do for sphere B. So for sphere A, we want to calculate the number of electrons. If we need to calculate the number of electrons, this is the formula. But remember, they were transferred between the two spheres. So there are two options of doing that. The easy way is to say number of electrons, it will be Q final for A minus Q initial for A, because the number of electrons were transferred. Initially, I was having this, finally, I was having that. That is why I'm saying Q final minus Q initial divided by the charge of electron. So it will be the charge of electron. So now, finally, after they made the contact, sphere A, the charge is 6 coulomb. So the charge is 6 minus initially for A. So initially for A was -8. So initially A was -8. It will be minus. This is the formula. The change, it simply means this part at the top. Okay, I'll do the second option. I'll do the second option. It will be minus into A, it was -8. So it is -8 divided by the charge of electron. So I'm doing this. I don't want to put the charge of electron yet. I will tell you the reason why. So now this is 6 plus 8. You write 6 plus 8, that will be 14. So 6 plus 8 is 14. Now the charge of electron, So now let us look at the physical constants. The charge on an electron. So this charge of electron is equal to -6 by 10 to the power -19 coulomb. So now, if I'm having that, I don't want to divide with the negative number there. So if the top part is positive, so the bottom part, it will be positive 1,6 by 10 to the power -19. That is why I wanted to keep charge for electron. I wanted to check the first part at the top. If the first part was negative, then I'm going to divide by negative. But the first part, the numerator, my numerator is positive, then the denominator will be positive. So you count the number of electrons in my calculator. You count, it will be 14 divided by let me do this. It's 14, then you divide by 1,6 exponent -19. So what I'm getting is 8,75 by exponent 19 electrons. So I'm getting 8,75, then exponent 19. So these are the number of electrons. So this is how you calculate the number of electrons. But if you prefer to use this formula, yes. Gazia prints.
I would like to find out, is there like a PDF of the questions that you're doing?
Yes, I'll do, definitely I will do that after this session, Miller. Okay, Miller. That one negative, you take it from the data sheet. So table 1. So the charge on electron, which is E, the symbol which is small e, is equals to negative 1,6 by 10 to the power negative 19 coulomb. You take it from the data sheet for paper 1. You'll be provided with the data sheet on Monday. So you get it from there. So the charge of electron is constant, negative 1,6 exponent 19. So I think I answered that question, Mr. Nambani. Okay, thank you very much, Sim. Remember that charge of electron is negative 1,6 by 10 to the power negative 19 coulomb. So now I wanted to keep not to substitute it. Now, why? I wanted to check my numerator first. If my numerator is positive, then I'm going to substitute that charge of electron as positive at the bottom. The reason for doing that, the number that I'm looking for the number of electrons being positive for that matter. So now, the second part, for this top part, we can calculate it, isolated, the change. It must be changed for Q for A. Once there's a change, it will be final minus initial. So it will be change for A into final minus, change. You can't just put change. You must put the charge. I'm sorry about this. It can be change and change. The QA final minus QA initial. I stand for initial, F stand for final. So finally, after they made the content separate, finally, it will be 6. So this is 6 minus initially I'm having negative 8. So it will be into negative 8. That is why at the top I'm having positive 14. Is a charge, positive 14 coulomb, because we have this formula here. So to calculate the number of electrons, then we can use this formula. The charge, you just substitute, it will be that 14 divided by, is being positive, 1,6 by 10 to the power negative 19. So you're going to get the same answer. Same applies to sphere B. If maybe one of you prefer to use sphere B to calculate the number of electrons, still fine. But this side, you're going to say the Q, Mr. Nambani, is it visible that side? Must tell me if This side. Okay, thank you. So it will be the number of electrons that will be, we can take from that side, it will be Q finally for B minus Q initial for B divided by charge of electron. So meaning Q for B final is the same as A. So it's the same as A. So it will be positive 6 minus for B initially 20. So it will be negative 6 minus into positive 20. So divided by the charge of that electron. So now you can see that I'm going to have 20 minus 6. So I'm going to get negative 14. So if this is negative, so now is when I'm going to substitute at the bottom. The charge for this, it will be negative 1,6. The charge of electron is there, negative 1,6 exponent negative 19. So it must be 1,6 exponent negative 19. So I'm going to get the same answer, which is 8. The number is 8,75 exponent 19 electrons. This is how you calculate the change. If you calculate the number of electrons transferred. So the number of electrons transferred between the two spheres during the contact. So that the question was not specific for A or specific for B, but if you use for A, you're going to get the same results as once you use for B. So by knowing that part at the top, the charge for, because you pick up the charge, it will be positive 1,6. It will be the mark for doing that. To substitute there, it will be the mark of substituting that part and also the formula and the final answer. That is why they awarded this question 4 marks. The total for this question was 14 marks, which is electrostatics. It will be it was 14 marks electrostatics. And Mr. Nambani for electrostatics and electricity, I think I need to move to maybe to paper 2, especially the last part for chemistry part. I'm not sure if they have some questions before I can go to the chemistry part. Abuelang? Amo? Amoela Mukoni? I can't hear from my side, Mtati Nambani. Five, 5, 2, 3. I'm not sure.
Sir, I was asking if what happened to 5.3 because I don't see any explanation there.
5. 5.2.3, I think this is the one that I said they must go and check the examination guideline, their definitions. I'm thinking, I think she's referring to 5.2.3.
Yes, sir.
To the right.
Oh, okay.
Yes. Mm.
Thank you,
Yes.
sir.
Okay, thank you very much.
So I was just going to ask this question, but it's okay.
Yes. Mm.
The new answer. So I would like to ask about the question 5.2.4. I saw after you I saw after you did the division, 1,6 times 10 negative 19 electrons. When you on your answer, the negative 19 was number negative 22. Is it a rule or
I hardly hear him that side. Can you just elaborate that? Hardly hear you. Mm. Mm. Okay.
yes, sir?
So, okay. Oh, no. Oh, now the question is asking why cannot be negative there. So actually, what we want to know, we want to calculate the number. How many electrons? How do you count? You can't say, if you count to 10, to say -1, -2, you count to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want that number being transferred from one sphere to another. So I think that the sense for that case is to count. We want to get the number. So specific, we want to get the number being positive. This is how you count. How many numbers of electrons are transferred? Not simply means because of the electron, it must be negative. The proton must be positive. You must indicate it because it's an electron, so it's supposed to be negative. No, we want the number of electrons, not specific to say we must indicate it is negative so that it's an electron. No, 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 no. We just look into how many numbers are transferred. So this is the numbers of electrons are transferred.
Sir, I just wanted to ask about my chat not working. I can't see any messages or send any messages in the chat. Is there something that you can do about that? Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you very much, Mr. Nambani. Then we can go to, all right. All right, I'm listening to.
Unfortunately, sir, we can't use the chat, sir. Okay, sir. No, sir, I don't.
Okay, okay. All right, thank you very much.
Sir, I was saying the chat is not working. Okay, thank you, sir.
Okay, thank you, Mr. Nambani. The part of chemistry, term 1, it was only the physics part, and term 2, physics together with chemistry. So I'm having nice questions for revision. So we'll start question 3, then we go to question 4. Thereafter, we can go to, I'm having question 5. That this is question 7, or this is question 5, then question 6, and question 7. So most probably 60%, 70% of the chemistry will be covered. So let me quickly start with question 3. The question 3 is the part of kinetic molecular theory, KMT. KMT, if you look at the structure of the paper, the state of matter and kinetic molecular theory. So now let me look at the marks for this part. Start with question 6, state of matter and kinetic molecular theory, 10 marks. Then we go to atomic structure and periodic table, it will be 22. Then chemical bonding, it will be 10. Physical and chemical change, 10. And also quantitative aspects of chemical change is 8 marks. So more or less, to save time, this is 10:36. I'll quickly rush to question 3, then question 3, then I'll do question 4. All right, let us look at this question 3. Okay. Again, to the right. Okay, let me do this. Let me adjust this side. Can you see it? Is it visible that side, Mr. Nambani? To the left, a little bit, left. Okay. Thank you, sir. Thank you, sir. So question 3. Question 3. Now learners investigated the effect of increasing temperature on ice cubes. So now if you talk about increasing temperature on ice cubes, you think of the two curves. There's a cooling curves and also the heating curve. I think they still remember those two curves. Now, the first part there, okay, before I can go to the table, let me go through to the statement at the top. They recorded the time and temperature of the ice cubes during the experiment in the table below. So the recording for the time is, it should be in minutes. The temperature was in Celsius degrees. So it was degrees Celsius. We have the table -10 up to 75. Time is 0 until 36 there. So before we start there, we remember we have the tools for scientific, why we need to investigate. So actually we want to investigate what? There's a relationship between the time there and also the temperature. So the time, we're going to talk about the dependent variables and independent the variables. So it's very important to know the dependent and also independent variable. So if you know these two, we can state investigative question. We can state investigative question. We can also, from this investigative question, then you can have your hypothesis. You can have a hypothesis from the investigative question. So now, the time, even if you go to mathematics, time is always in x-axis. So I can take it as the independent variable can be my time. So the dependent variable, so it will be my temperature. It will be the temperature of what? We talk about the ice cubes. Meaning if I'm using this, is it a cooling curve or is it heating curve? So you must be careful with that one. I'm having ice cubes. So you look at the temperature. The temperature, -10, -5, -1. So when the time is 6 minutes, that will be the temperature. After 9 minutes, that will be the temperature. So this is the learners, they recorded this table there. Then now, let us look at our questions. The first question, write down investigative question for the experiment. So then you need to start with, normally the investigative question, how and what. So we can use this one and we can also use that one. So it will depend which one you prefer. Once you state the investigative question. So I'm not sure which one you're comfortable with, but now, what is the relationship between what? The increasing temperature. So because remember, the temperature is one of the factor, and the time is one of the variable. So it will be independent variable. This one, it will be the dependent variable. So how does, let me start with this one. How does an increase in temperature, how does an increase in temperature and time affect the effect of the ice cubes. So I can put as question mark. So I'm not sure from your side what you feel about this one, because remember what I need to do here. I need to check what I'm investigating here. I want to check the effect of ice on temperature as well as recorded time. So if I can say, how does an increase in temperature, I'm looking to the increase in temperature now and time affect the effect of the ice cubes. Or what can I say about the what? You will tell me from your side your view to this investigative question. You can say, what is the relationship between the time and temperature? Then, what is the relationship between the time and temperature on ice cubes? So then remember, at the end, you just put the question mark. So this is how I feel if I was the one who was doing grade 10 answering this question. More or less, I need to indicate the time and also temperature as one of the dependent and also independent variable. So you'll check the phrasing of the statement. Maybe you have a better way of how to phrase it, but at the end, we need to check whether you have independent as well as the dependent variable. Sorry. All right. So that will be the investigative question. That will be my investigative question. All right, let me check 3.2. 3.2, study the data in the table and write down the what? The independent variable, the dependent variable. The independent variable, it will be time. So after 9 minutes, what will be the temperature? Because remember, I'll be using thermometer to measure the temperature. So if I'm using the thermometer, that will be the temperature indicated by the thermometer, it will be 0. After 15, it will be 16.5. After 18, 28, and also somewhere there, we check, we have 75, 75, 75, it comes to be constant. All right. So now the dependent variable, that will be my independent time. So this one, it will be my temperature. So definitely this one, it will be my temperature. All right. Then now make use of, use the information in the table above to draw a graph of temperature versus time. So my criterion, they were asking me, once they don't indicate, is it a graph of, is it bar graph? No, it cannot be a bar graph for for this part of heating curve and cooling curve, the time when we were doing the experiment. So they wanted to draw the bar graph. I said, no, it can't be the bar graph, but must be a line graph. So it must be temperature versus time. So meaning I must have the heading, the temperature versus time, then I need to draw the graph. So I did try to draw it. I was struggling with the scale. So I wanted to draw this, this graph. Initially I started with -10. I started with -10, -5, 0, 5, 10, up to 40. So I've realized that this is not going to fit my points, which is the temperature in y-axis, because the temperature reads from -10 to 75. But my scale is -10 up to 40. Then I had to change the scale. So I had to change the scale. I was doing trial and error this side. Then I changed the scale from here to there. So it will be, okay, let me just start it from here. 10, somewhere is 20, 30. Why 20? Let us look at this part. 0, 2, 4, 6, 8, 10. 0 again, 2, 4, 6, 8, 10. Because this is 10, 10, 12, 14, 16, 18, 20. Then 22, 24, 26, 28, 30. So then I came up with the scale until I get at the top there where I'm having 80. So where I'm having 80. So I was quite happy because that one I was saving up to 40, but this one is up to 80 somewhere there. So because of my temperature, it started on the negative side. So I'm going to have -10 there, and 0 it will be somewhere there, and +10 it will be somewhere there. So if you look at the temperature, the time is 0. So the time is 0. So meaning here, I'm going to have time in minutes. So on y-axis, I'm going to have temperature. I'll be having temperature in degrees Celsius. Then now I can have the heading. So it will be the temperature versus time. Temperature versus time. Normally, the science people, they start with the heading first, the temperature versus time. This is temperature, it will be my dependent variable. The time, it must be also in minutes. So even the time I scale there, 0 up to 36. So I wanted to check. If I'm using this is 0, this is going to be 10. This is going to be 20. This is going to be 30. This is going to be 40. So I did manage to get the graph. So I plot the graph. If the time is 3, then that will be the temperature. I had the point. So if the time is 6, so I had a temperature which is -1 somewhere there. That was the dot. So then ultimately, that will be the line graph. I join all the points. So I join all the points, and ultimately, somewhere there at the top, if you look at the part at the top, so it's 75. Once the time is 30, the temperature is 75. Once this is 30, this is 30, the temperature 70, this is 80, 75 was somewhere there. So I had a dot. So when the time is 33, so the time is 33, corresponding point, that was the point at the dot, sorry, the point at the top. So, and also 36, that was my last point. So more or less, you're going to get this type of a graph, we know. So this one, it will be a heating curve. So a heating curve, so you can have the type of a graph like this. So they'll mark the part of the temperature and also the time which is being labeled. 2 points that are correctly plotted. It will be the marks for that one. Then the last mark can be the shape of the graph. We can have the mark for that one. And also, I think we can award the y-axis and x-axis because this is counting 5 marks. So sometimes you'll get the type of a question in examination. You must be in a position to read the graph. Like I indicated earlier, I was struggling to get the what you call the scale, but I've managed to say if I reduce my scale, ultimately you can get the correct graph for that method. Okay, that was question 3.3. So now, if you look at this one, explain why the temperature remains constant from 30 to 36. So why the temperature comes to be constant for that method? Oh, so I think this question, think of what? Think of the boiling point. So the temperature will boil once the temperature is 100 degrees Celsius. Né? So this is what you know. The boiling point of water is when the temperature is 100 degrees Celsius. So as much as you are trying to boil these ice cubes, the temperature somewhere there, it comes to be constant at the top there. So meaning it will be the last part of gaseous phases, it comes to be constant. We can say now just try to talk about it comes to be constant because to reach the point of the boiling point. The boiling point, as we know, but we know the boiling point must be exactly 100 degrees Celsius. As much as we are going to record the time there, it can be 36, 37, 38, 39, it comes to be constant. It comes to be constant. It can't boil more than that. Because once it comes to be constant there, what do you expect? Maybe you're expecting to say, all right, it can be 80, Mr. Scharume, it can be 90, because you're talking about boiling point so that it can reach 100. But if you look at this sketch, you start from, remember, the 3 phases of matter. If this is an ice, you start with a melting point, then you'll go to, it's a solid, then we have liquid, which is the boiling point. Then we also have the gaseous phase. So now we need to be careful with this part. If for instance, let us look at the 2 points here. I'm having 38 and 38. You can say that 38, it must be phase change. So it can be from a solid, then the ice is melting, the ice is still melting, then we can have phase change to liquid, then we can have phase change to gas. So meaning this part, it will be a phase change. Phase change. So you go back to your notes and you must be able to label, because sometimes in exam, they'll ask you to label from A to B, or maybe B to C, C to D there, and D to E, and E to F. So we need to be careful with that one. They can ask you to label C to D. What will be C to D? It must be phase change. Which phase? Is it liquid? Is it solid? Is it gas? So yeah, you need to go back and check those phase changes. But actually, this question was referring to 3.3 to draw the graph, which is the line graph, and the last part to explain why the temperature remains constant. So it remains constant because now it must be the phase change. So maybe it can be the boiling point. The water is boiling because of that temperature being constant at the top there. So I think it makes sense. It will be also available if you want this question, as one learner requested that Is it the PDF of this question is going to be available? Yes, of course, it will be available, as well as the answers for that question. You'll go and look at the memorandum, and you have your own view to answer that 3.4 for that matter. All right. I'm not sure, Mr. Nambani, to question 3, or should I do question 3 and question 4? Then I'll wait for the questions so that I'm checking time. It's 10:56. It's almost 11 o'clock. It will be 1 hour left. So we need to move on. We need to move on. Let me do question 4, then I'll take some questions before I can go to question 5, 6, and 7. All right. Question 4, bromine is a non-metallic element with atomic number of 35. It can exist as an isotope. Thank you, Mener. A bit to the right. Thank you very much, Sam. So now the first question there. So isotope, we define what's an isotope. An example, if there's a bromine, is B, or let me just use this one of, I think the chlorine. Most probably people, chlorine is 17, chlorine is 17, can have 35,5, can have 37. So what is at the top there? It will be the atomic number, the number of protons are the same. If you look at the top part, having the same, the number of protons, or you can say the same atomic number, but what is different is what is at the bottom, meaning I'm having 35,5 and 37, so it can be a mass number. So an isotope also should be there in exam guideline. Is different. Either you say is the same element, same element having the same atomic number with a different atomic masses. So you can say it can be having the same number of protons, if the number of protons, but different number of neutrons. So remember, we have neutrons and electrons. All right, so they can quickly check the examinable content or the terms and definitions. So it will be definitely to be there on Monday, which is tomorrow. So use the suitable calculation to determine the relative atomic mass of bromine when a sample consists of 50.69% of bromine and also 49.31% of bromine. So now what we need to calculate, atomic mass of the bromine. So normally that will be plus or minus 4 marks. So to do that, you are going to say, all right, I want to have a clean page for 4.2. So 4.2, this is 4.2. Calculate atomic mass, relative atomic mass. So now of bromine. So now what I'm having there. So I'm having the bromine 79, 81, 79, and 81. So meaning the first part. What I like about this one, you don't take the top part. Atomic number is the same. You don't take that one, but because they want the mass, you look at the mass of that element. Now they're talking about the bromine. You look at the mass is given 0.69, then you multiply by 79, plus Mr. Nambani. If I do this, can you see that side? Yeah. More than. Yes, I'm there. Device settings. It doesn't want to. Yes, it's only that option. I don't know what happened to this side. Definitely it's off. I don't know why it's off. I'm letting it on. No, there's no light shading. No, sir. Yes, now it's back again. Okay, thank you, sir. So let me, can you see the full page, question 3 and 4? Or question 4, okay, question 4. Focus, I must go to 3 dots again. Or focus, all right, I see it, focus. Okay, thank you, sir. Now we calculate the relative atomic mass. So we don't consider those atomic numbers or the number of protons, but we only consider the masses. So the mass is given 79, and the percentage abundance of that one is 50,79. You say plus, the other one is 49,31, then you multiply it by 81. To multiply by 81. So the percentage, if you add all of them, they sum up to 100. So now you just press the calculator. So just quickly, I'm just quickly going to say 50,69 multiply by 79, close bracket, plus 49,31 multiply by 81, close bracket, then divided by 100, so 79,79, 2 decimal will be 99, so this is equivalent almost 80, so meaning now this is how you calculate it. So you calculate, so simple formats, relative atomic mass for the bromine, it will be 100, it will be a mark that will be awarded this part and that part and the final answer. That is why we get 4 marks for that one. 4.3. Okay, Minna. Yes, from the calculation itself is 79,9862. So for yes, the calculator. Thank you, Miller. All right, 4.3. So complete the following table by writing down only the number and example. 4.3.1. Maybe you don't have to copy everything. Just write the number. 4.3.1 and the correct answer in your answer book. An example. 4.3.7 is in isotopes. All right, 4.3. Complete the. I'm having atom or ion formula Mg2 plus Cl2. 4.3.5. Okay, now this is the number of protons is 12. Numbers of electrons, we need to calculate that one. So 4.3.1 to 4.3.5. to 4.3.6, 4.3.2, then 4.3.3, 4.3.4, 4.3.5, 4.3.6. Right. Now, I'm having magnesium ion. I'm not having magnesium, but what I'm having magnesium ion. What does that indicate to me? Magnesium in the periodic table is 12. So now the mass there is 24. But if I'm having, remember, the number of electrons is equal to the number of protons. If I'm having this, I'm having 12 protons, I'm having 12 electrons. But if I'm having magnesium ion, this is group 2 in a periodic table. So magnesium is going to lose 2 electrons. So it comes to be an ion. If you talk about the magnesium, so meaning magnesium is going to lose electrons. You can't lose the protons, because the protons, they're at the center there. There's a nucleus, is surrounded by the number of protons and the number of neutrons. But now in Bohr model, outer energy level, we talk about the electrons. I can lose electrons, meaning the number of electrons, I'm going to lose 2. What will be left? I'm going to have 10. I think I can complete it here. So now it will be my number of electrons. But now how do I get the number of neutrons? So to get the number of neutrons, you go to that formula, is A is equals to Z plus N, if I still remember very well. So now this, it will be relative, talk about atomic mass. This is the mass, molar mass, let me say atomic mass. Atomic mass. So the Z, the number of protons. So this one, it will be the number of neutrons. So then I'm having, okay, this is the formula. So what I want to calculate, I want to calculate the number of neutrons. So the mass for magnesium, this is 24. The number of protons, is 12. You can't change it. It's 12 plus you have an n, so it will be 24. 24 minus 12, so it will be my n. 4 minus 2 is 2. 2 minus 1 is 1. So this will be the number of neutrons. So I'm happy about the number of neutrons. So I'm going to get 12 on that side. All right. So you do this. If I'm having the ions, I know definitely it will be, I'm going to lose an electron. But what about if I was having O2 minus? If I'm having oxygen is 8, then this is 16. But if I'm having 2 minus, which is n ions, negative ions, is group 6. To get group 8, I need 2 electrons, meaning it's gaining 2 electrons. But once it's 2 plus, it's losing 2 electrons. Okay. Thank you. Okay. Yes. Okay. Okay. All right. Okay, okay. All right. I assume that they followed from my example. Let me start it here, Mr. Nambani. Yes, okay, Mr. Nambani. So an example: chlorine. I'm having 17. I'm having 17. So meaning we know 17, which is the atomic number, the number of protons in the periodic table. But then this chlorine, I can have 35,5. They must go to a periodic table and check the chlorine is 35,5. Now this question, because the chlorine can occur as abundance of, it's an isotopes, same number of protons, but different, the number of neutrons. But it can be same number of, it should be same atomic number, but different number of what? Different mass number. So now if I put 37 there, it will be same atomic number. But what is different? It will be that part, which is different mass number. Is 35,5. This one is 37. 4.2 is the bromine, the Br. So Br, they go to periodic table and check the atomic number in a periodic table. But the mass is given as 79. The other one is 81. So the top part we don't consider because it will be same atomic number as a bromine and a bromine. What we need to consider is 79 and also 81. What is different is mass number. So what we need to calculate, we need to calculate atomic mass of the bromine. I think Mr. Nambani made it clear to that one. So now to calculate relative atomic mass, so what is given there? So they provided with the mass only, 79 and 81. These two are the two different masses, but with the same element. Atomic number is the same, or the same number of protons, but different number of neutrons. If I need to calculate the number of neutrons on this one and that one are different. All right, so to calculate that one, so 4.2, use a suitable calculation to determine the relative atomic mass of bromine. So you can say relative mass of what? Of Br. I'm specific now. I'm calculating relative atomic mass for bromine. So this bromine, it has two different abundance, which is 50,69, and the other one is 49,31. So okay, all right. This 50 will go with that 79. You say plus, that end it will be plus. This 49,31 will now go hand in hand with 81. That is why here I'm saying it will be 50,69. You multiply by 79. It will be the first part. It will be the first part. Plus, now the bromine is 49,31%. So you write 49,31 multiplied by that 81, not 79, because you are done with this part, 50,69 with the 79. The second part is that one, 49,31 with 81. So if you add the total of the percentage, it's out of 100. So always it will be out of 100. Even if you get, you have the same element, bromine, and also bromine that side with 81. Suppose that this one is 85 and percentage. So that percentage, once you add the percentage, three of them, they must give you 100. If you add 50,69 and also 49,31, you must get 100. All right. So you will say the top part divided by 100, you get 79,99. So if you get the whole number, so I decided to say 79,99 987, mama. So it's almost equal to 80 there, 80, 80, 80. Thank you very much, Ntate Nambani. Thank you very much, Ntate Nambani. So for 4.3, slow down. That 160 kilometers per hour is not going to work for me. A little bit to slow down to this one, 4.3. I'm having atom or ion. So this one, Cl2, the chlorine is an atom. Mg2 plus, it will be an ion. All right, there's a number of protons, the number of electrons, the number of neutrons. Thank you very much. So let me start to explain this. I wanted to explain the magnesium, which is Mg, but this one is magnesium ion. There's difference between the two. Magnesium periodic table is 12 atomic number. The mass is 24 there. Okay, so but what is important to fill this table here? I'm not interested to 24. I'm interested to atomic number. So which is the number of protons? Here we talk about the number of protons. The number of protons. The number of protons. I'm interested to that atomic number is the number of protons in the nucleus of an atom. So it is an atomic number. So the atomic number is the number of protons.
I was going to say the same thing, sir.
All right, thank you. I'm sorry about that one. Thank you. So magnesium atomic number in the periodic table is 12. Then the mass is 24. What is atomic number? Is the number of protons in the nucleus of an atom. So then that's an atomic number. All right. So, but now I'm having an ion, is Mg2 plus. To become an ion, what is happening there? Group 1, group 2, group 3. So this element, on the left-hand side, this talk about the metals. On the right-hand side, you have the non-metals. So group 1, I know sodium is group 1. So if sodium is group 1, so sodium is going to lose an electron, so it comes to be an ion. So normally we do this once we talk about the ionic bonding. And as an example, if I'm having sodium chloride, this cannot be a covalent bond. It's an ionic bond because sodium is a metal. The chlorine is a non-metal. So we talk about what? Ionic bond. The type of bond here is ionic. So meaning it's a sodium is going to lose an electron because it's group 1. Magnesium is group 2. So how many electrons is going to lose? It's going to lose 2 electrons so that it will see itself as noble gases. Once it's going to lose this, so it's going to have 0 electrons. So once it's going to be 0, it will correspond to that element, the last group in the periodic table, which is group 0. That last group in the periodic table, which is the noble gases, group 0, or the inert gases. All right. So if this is aluminium is going to lose how many electrons? Is group 3. It's going to lose 3 electrons, so that comes to be an ion. So now I'm having a magnesium ion. Magnesium is going to lose electrons. So it's going to lose 2 electrons because now magnesium atom, I'm having for this one, okay? This one is magnesium atom. This one is magnesium ion. You need to be careful. If it comes to be an ion, it's going to lose 2 electrons. So now from 12 to to lose 2 electrons, how many electrons will be left? It will be 10 electrons. It will be 10 electrons. But how do I calculate the number of neutrons? So to calculate the number of neutrons, I'm going to say A is equal to Z plus N. So this is my standard formula. So to calculate the number of neutrons. So my A, it will be my A is for what? It's for my mass number. It's mass number. So mass meaning I refer to this in a periodic table. If you talk about the mass, it's my mass number. What about the Z? It will be the number of protons. What about the N? It will be the number of neutrons. So meaning specific, I'm looking for the number of neutrons. So you can say A, the mass for magnesium. Mass for magnesium, that formula A is equals to Z plus N. This is 24 is equals to the Z, the number of protons is 12. You can't lose the protons, you only lose the electrons. It will be 12 plus N, so our N, it will be equal to 12. So it will be equal to 12. This is how we do that one. But if the same question, chlorine, if now you look at chlorine ion is group 7, it's a non-metal on the right hand side, so it's an halogen, so meaning chlorine on left hand side 5, 6, 7, those elements on group 5, 6, 7 to get group 8, they need to gain of electrons. So meaning group 1, 2, 3, it must be loss of electrons. What about the chlorine? Chlorine is group 7. So the Lewis structure, I think they know the Lewis structure. So to get group 8, I need only 1 electron. To do what? To obey an octet rule so that I can become an ion. The octet rule, it must be maximum of 8. Maximum of 8. So where do we get that one? I'm going to get it from sodium. Sodium, it will be group 1. So meaning if maybe I need to explain this. So it will be sodium. So sodium is going to lose an electron, so that comes an ion. So now the number of electrons are equal. So this one is going to lose electron, but if it's going to lose, somewhere there is going to be received by what? By the chlorine, so that it can have the maximum of 8. So this one, it will be ionic bond. But now the question is, I wanted to explain if the chlorine, as an example, chlorine ion, how many electrons do we have? Okay, chlorine is 17, here is 35,5. This is chlorine ion, meaning I'm going to gain 1 electron. In terms of number of electrons, it's not going to be 17, but it's going to be 18, because chlorine is going to gain 1. If we talk about oxygen, which is oxygen 2 minus, so oxygen we know is 8. The last group, oxygen, this is 8, 16. But now to get group 8, okay, I'm going to do that. I think once I do question 5, I'll explain the Aufbau diagram. So we look at the outer energy level. Outer energy level, oxygen, if you're referring to the number of electrons, I'm having 8 electrons, but if I'm having 2 minus, so I'm going to gain 2 electrons. So the number of electrons on this one is going to be 10, not 8. If it comes to be an ion. If this is 2 minus, it's going to gain 2 electrons. If it's Cl minus, it's going to gain 1 electron. The chlorine atom is an atom, not an ion. Chlorine is 17. Once it becomes to be an ion, it will gain 1. So I'll be having 18 electrons. This is oxygen. The number of electrons is 8, but now once it becomes to be 2 minus, it's going to gain 2 electrons, so it's going to be 10. I think that one was explained. Everyone is happy about this, so we can move, we can move, we can move, we can move. So we can fill this table. Remember, you must not copy this one, but you must write 4.1, 4.3.1 up to that one. So I'm having this chlorine 4.3, 4.3.2. This is how we calculate the number of neutrons. 4.3.5. 4.3, the number, we talk about Cl2 now. I'm talking about Cl2, not Mg2 plus. So Cl2, the number of what? The number of 4.3. I think I must go to 4.3.3, not 4.3.5. 4.3.3, the Cl2 chlorine atom, the number of protons, how many protons do I have? I'm having 17 because it's an atom. So how many? The number of electrons, it will be the same, which is 17. Then how many? The number of neutrons. How do you calculate the neutrons? Then you go to formula to calculate the neutrons. I will say, okay, now this is the chlorine. The chlorine, this is 17, 35,5. So this is A, this is Z, this is N. Now, this is chlorine. Chlorine, this is the molar mass is 35,5. But the number of protons is 17. The number of neutrons, it will be N. So to get N, I'm going to say, all right, I'll be having, let me switch off, actually, mute the phone. 35,5 minus 17, I'm having 18,5. I'm having 18,5. So I'm happy. I'm happy about this one. I'm happy. I think they're also, my learners are also following that side. So it's 18,5. So I think they follow now. That speed of 160. At least now moving with 100 kilometers per hour. So this is 18,5. Is visible to everyone. So okay, now 4.3.5. So now you write what the atom. So 4.3.5. I'm having 13. This is the number. This is an element. It's 13 there. So this is the number of what? The number of protons. So if this is 13, what's that element? Check the periodic table. 13 periodic table, it will be what? It will be my aluminum. So it will be my aluminum. So what will be the number of electrons? It will be the same as the number of protons because it's not an ion. So it will be the same. Then I'll be having 13 there. So now this is how we answered that question 4. So it's total for question 4. That was 12 marks. So it's almost 11:30, 30 minutes left. 30 minutes left. And at the number, I'm sure they are happy with this one. 4.3. Focus. I did press it. Is it any changes that side? Okay.
Sir, I just wanted to ask about the graph of the time, temperature versus time. When they say that we should draw it in a bar graph form in the exam, should we draw it in line graph?
Okay. Yeah, yes, actually, my learners, they were asking me, how do you draw this graph? Because it's not specific here. Ne? So always once you draw that one, it will be a line graph. So it will be a graph like this one. It can't be a bar graph. All right.
Thank you, sir.
All right. Okay. And the Nambani, question 5 and question 6 from your side, you can see both 2 questions, 5 or 6, or should I zoom for 5 only, then 6 later? Okay. Tembi?
Okay, so my chat option is being disabled. Yes.
Okay, thank you, Mr. Nambani. Question 5, 10 marks. 10 marks, question 5. The questions or question below are based on outbound diagram of a certain element represented below. So this is the outbound diagram. So they know normally in the outbound diagram, it will be the energy levels. I'm having energy 1. So it can have energy 2. Obviously, this one, it will be the third energy level. So meaning now the ground state there. So once electron, if you move from energy 1 to energy 2, the electrons are excited. Talk about once you move from the excited state to fallback, it will be the part of the syllabus in grade 12 once we deal with line emission spectrum and then absorption spectrum. But for grade 10, you define valence electrons. You define valence electrons. If an example, oxygen is group 6 in a periodic table. Ne? If this is group 6 in the periodic table, how many valence of electrons does this element have? So 2, 4, 5, 6. So now valence electrons, meaning it will correspond to a group of, if supposed to be oxygen is group 6, so meaning oxygen is having 6 valence of electrons. If nitrogen is group 5, so meaning nitrogen, so nitrogen I'm having 5 valence of electrons. So this is valence electrons, and valency of electrons. So valence, normally we check, you check the outermost energy level. So now energy 3, it will be the outermost energy level. So now the valence of electrons, it will be what? To define the valence electrons, you are saying electrons in the outermost energy level of an atom. It will be the outer 5 point, if I need to 5.1.1. So it will be those electrons in the my handwriting, outermost energy level of an atom. So meaning you consider the outermost energy level. So that will be our valence electrons. So meaning I'm having the valence of electrons. So for this question, how many valence electrons are there in this group? So how many valence electrons? Because it's the outermost element. 1, 2, 3, 4. How many electrons are there? So you're going to say it will be 4. Then now, write down the SP notation of the element represented above. So SP notation, you start with 1s, say 1s, you go to 2s, 2s, then from there, I'm having 2p, then I'm having 3s, I'm having 3p. So we need to write that one. We look at 1s, which is the ground state. How many electrons are there? It will be 2. 2s, maximum is 2. 2p, 2, 4, 6. 3s, 1, 2. 3p, that is 1, 2. This is how we write SP notation. So this is how you write SP notation. SP notation. So now write down the name and symbol of the element represented above. So now the name and also symbol. So I'm having how many electrons or how many protons do I have? 2, 4 plus 6 is 10. 10 plus 4, that will be 14. So you check period table, atomic number. If you have 14 there, it will be that element. So that element, write down the name and also the symbol. So you say the name, it will be silicon. And the symbol for the silicon, that will be Si. Because you know, 14 there, how many electrons do I have? 14, the number of protons, which is the atomic number. Atomic number is the number of protons in the nucleus of an atom. So this is 14, so you know that will be silicon. So 5.2, draw the output diagram of oxygen ion. So we need to draw this, but this time we draw for oxygen ion, meaning O2 minus. O2 minus. So now to draw 5.2, so I'll be having energy 1s, so energy 2s, 2p, 1, 2, 3. Maybe to go to, remember oxygen. Oxygen, I'll start with the one that I know is 8, then is 16. But now this is O2 minus. It's gaining 2 electrons. So if it's going to gain 2 electrons, it will be the same as neon, because neon, I think, is having 10. So meaning I'm going to have 10 there, not 8 plus 2. I'm going to add plus 2 because it's an ion. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an oxygen atom, but oxygen ion gaining 2 electrons, 8, 9, 10. So this is how you draw an Aufbau diagram of oxygen ion. So we are drawing Aufbau diagram for oxygen ion, So you say energy 1, you can have box or you can have a circle. So I'm having the maximum of 2. Then you go to second energy level, 2s, meaning the opposite spin. Then you fill this one first, 1, 1, 1. Then after you fill the remaining electrons. This is how you represent. So it will be 1 mark for this one, 1 mark, and also 1 mark for that one. That was 3 marks to draw Aufbau diagram of oxygen atom. That was 10 marks for this question. Question 6. I think energy and chemical change. The last part, sulfur burns in oxygen to produce sulfur dioxide gas. So now write down a balance equation for the reaction between sulfur and oxygen. So we need to write down the balancing equation for sulfur and oxygen. So to say, let me have the clean page. The clean page, sulfur is a solid 6.1. 6.1. Sulfur, I don't think the phases are important, but sulfur is a solid, so that plus oxygen is a gas. So it's going to give us what? Sulfur di means 2. That will be also 2, so it will be the gas. So meaning this is one of is a exo. It's an exothermic reaction. So what is an exothermic reaction? The energy is released by the system. If they ask you tomorrow, so what's an exo? So meaning this is talk about there's an exo and there's an endothermic reaction. So it's an exo and endo. So this one energy is absorbed. This one is energy is released. An example of exothermic reaction, if I'm having A plus B, I get C plus energy, that side. So this plus energy as a product, it will be the type of exo. But the energy was absorbed by the system. If I'm having A plus B plus energy, that's going to give me C, so it will be endo. So this one, exo is hot, endo is cold. So to remember this, how I'm going to remember, if I'm using the thermometer. If I'm using the thermometer, so this is an example, I'm using ice in this example. So this is A. We want to know what is an exo or endo, because I know this topic it will be the part of the synthesis reaction, the composition, exo and endo. So this side is B, water. Then I can have the same the thermometer to measure the temperature. This one, okay. That water is hot. The reading for the thermometer, the temperature is going to drop. So the temperature is going down. So it's inside. The temperature is dropping inside the container. So it will be the part of inside. It will be endo. Endo is inside. But the temperature, if this is hot, is going to exit. It's going out, it's going up. The temperature is raised, meaning it's going out of the bucket or that container to exit. It will be exo. So exo is hot because of the temperature. The endo is going to absorb the energy, but that one is out, exit to release the energy. We need to be careful with endothermic reaction. Look at the definition of endothermic reaction. The energy is absorbed by the system. Exothermic reaction, the energy is released by the system. Look at those two definitions. Okay, but now 6.1. Write down the balance equation for the reaction between the sulfur and oxygen. I'm having sulfur and oxygen, so now I need to balance it. You are only allowed to use the pencil. Just try to use the pencil so that it will be easy for if you want to make the changes here. So it will be using a pencil, I'm having one sulfur this side, I'm having one sulfur that side, I'm happy about it. But this side, I'm having 2 oxygens, I'm having 2, this one is balanced. So this one is balanced. Now, it will be 1 mark for the reactants, so it will be 1 mark for the product, and it's balanced, so it's balanced, that one. Then 6.2.1. is the following statement correct? Is the following statement correct? The mass is conserved when sulfur burns in oxygen to produce sulfur dioxide. So now the statement can only be correct if this is balanced. But if it was not balanced, it will be incorrect. So now the mass is conserved, meaning this is the conservation of the mass. If they ask you to state the conservation of mass, the total mass in isolated system, it remains constant. So look at the conservation of mass. The mass is conserved, meaning the reactants and the product will be the same. So meaning this, it will be one of the chemical change. There's a physical change and also the chemical change. The chemical change, the reactants and the product are not the same, but the physical change, the reactants and the product is the same. No changes as the reactants and the product. But the chemical change, there's a change of the reactants and also the product. You need to be careful with that one. So now 6.2.2, explain the answer in 6.2.1 with the calculation to say the mass is conserved. So this is where you go to periodic table. You go to periodic table to say, okay, I'm having sulfur, I'm having 2 oxygens, I'm having SO2. So I know this is balanced. The mass can only be conserved if the reaction is balanced. So it's balanced. So I'm happy about that one. If you look at periodic table, the mass of sulfur there is 32 plus. How many oxygens do I have? I'm having 2 oxygens. But look at the mass of oxygen in the periodic table. So you see this is 16. So that side, I'm having sulfur. Sulfur is 32 plus. How many oxygen do I have? It's 2 into 16. So you want to say, you want to calculate the conservation. 2 is 32. This side 32, 32. So I'm having 64. That will give me 64. So 64 is equal to 64. Then now the statement, now explain the answer with the calculation, because you said yes. Is the following statement correct? It's a matter of yes or no. It is correct because now this is balanced. This is balanced. So I'm happy. I'm having 64. I'm having 64. Then it will be awarded the mark for that one. So I'll be having the mark knowing the sulfur and knowing the oxygen and also this side. So it will be 4 marks for that matter. So I'm happy. I'm happy because my calculation is 64 and 64. So I can smile. So on 6.3, name the type of chemical bonding in sulfur dioxide. So you look at sulfur. Sulfur in a periodic table, is it a metal or non-metal? So meaning if sulfur is a non-metal, which is sulfur together with oxygen is a non-metal. So non-metal and non-metal will give me covalent bonding. Covalent bonding is to share electrons between atoms. If you talk about the sharing of electrons, we talk about share of electrons. So if you're sharing the electrons, we are referring to a covalent bonding. For question 5 and question 6, more or less 20 marks, we are done with that one. So it's almost 10 minutes before 12. So let me just quickly, I'm not sure from that side if there's any question, Mr. Nambani, before I can go to another question. If there's no hand, allow me to do the next question. Okay. Okay. Yes. Yes. Okay. Ma'am. Uh, I can see from my side. So should I switch my camera this side? I must go to 3 dots, device and setting. Then is turn off incoming video. Where is camera now? I'm looking. I don't see it.
Yes, I can see it in the Nambani.
Oh, okay.
Sir, morning, sir. I would like to ask, are the waves and sounds going to be the multiple questions? Yes, sir, I can see it, sir. No, sir, thank you, sir.
Good morning, sir. Sir, I still haven't been able to fill in the register. I'm still struggling. Yes, sir.
So I just wanted to ask, what if like at your school you didn't cover a specific topic? Is it still going to be in the exam? Okay, sir. Thank you, sir.
I was gonna ask the same thing, sir. Yes, sir.
Thank you very much, Ntate Nambani. I'd like to start first by thanking the colleagues who organized this last push measures to ensure that our learners are going into the examination prepared, or rather ready to say this is what we are going to be asked on. Colleagues, thank you very much from all the districts, and to all the learners who attended. Thank you very much, and we hope that this is going to benefit you to the latter, because 150, the paper is what is out of, and 150 is what we expect out of you. Ntate Sekharume, thank you very much for all the effort that you placed into simplifying all the subtopics that you had covered. Ntate Nambani, thank you very much and enjoy the day.
Yes, sir. I actually enjoyed the session because it helped me understand the parallel and the series circuits better, because I hadn't really quite revised on that. And then when you got to the heating curve, I understood that I'm supposed to do a line graph instead of a bar graph. And I think that really helped me in terms of my marks and everything. And then when he like really in depth explained the equations of how of the ions and all of that, I really understood how I'm supposed to answer the questions, and then how I'm supposed to approach the answering of the question. So I think that really helped me. And also the Aufbau diagrams and all of that. Like I understood how I'm supposed to like visualize it and understand the concept of the work and drawing it, so that I can be able to answer the questions. So I really like appreciate all of that, sir. Thank you.
Thank you very much.
Thank you. So I would like to ask in the Piscarumi if we must write, if we write the exam, we must write every topic in the new page. Okay, sir. Thank you.
Thank you, sir.